Good day. We are Group 4, and our discussion will center on our chosen journal article entitled Improvement in Benthic Habitat Environment via Granulated Coal Ash in a Water Body Exposed to Wastewater Discharge.
The discharge of untreated wastewater into a water body deteriorates the benthic habitat of bottom sediment. The depletion of dissolved oxygen via the consumption of oxygen by the reductants induces degradation in the biological environment. With this, the use of granulated coal ash or GCA, a byproduct of coal-fired power plants, showed the potential in lowering the diffusion of reductants. The absorption of these substances and the increases in the oxidants dissolved from GCA are thought to play an important role in improving the benthic habitat quality in the sediment. In the current study, field experiments were conducted in the Fukuyama Inner Harbor in Hiroshima, Japan, to examine the effects of granulated coal ash on improving the benthic habitat environment under hypoxic water conditions. Specifically, the benthic habitat quality in granulated coal ash, gravel, and sediment cages placed on the seafloor was examined over time. In addition, the benthic habitat quality in a tidal flat made from GCA was also investigated. Furthermore, analysis of the pore water quality in the cages and the GCA-made tidal flat were also observed.
We recall that the decomposition of the organic matter within the sediment causes a low redox potential at which huge amounts of reductants are released. These reductants are what consumes the dissolved oxygen and causes hypoxia or water conditions where the concentration of oxygen is so low that it is detrimental to the benthos. As a solution, it appears that the removal of the reductants released from the anaerobic digestion of organic matter plays an important role in the improvement in the benthic habitat environment. In other words, a material that can remove reductants is effective in improving the benthic habitat environment. Results from this study shows that the granulated coal ash or GCA is an absorbent that can be used to remove reductants, not just because there is a higher redox potential and higher rate of water exchange in the GCA and gravel cages due to their large pore volume, but also because of the dissolution of the chemical components of GCA. One of the primary components of GCA is calcium oxide. When calcium oxide dissolves, it increases species richness in the GCA cage because it releases hydroxyl ions that can reduce the acidification of the sediment caused by the anaerobic decomposition of organic waste. Furthermore, some useful ions in the biological environment, such as silica and iron ions, are also released during the dissolution, which also increases species richness in the GCA cage.
Would it be successful in the Philippines? It would be possible to integrate this study in our country. Bodies of water like the Manila Bay and Pasig River would benefit if done correctly. In an article by Rafales in 2019, it was stated that many businesses, large or small, dump their untreated wastewater in Manila Bay that causes it to further deteriorate. Any rehabilitation done would not be effective if incorrect methods would still continue. If this technique were to be done in our country, it would take a lot of effort, discipline, and cooperation. It should start with the authorities, whom, if not all, accept bribery just to turn a blind eye to the foul ways of businesses. Filipinos, especially public officials, should be disciplined enough to know the correct way of disposing waste. If all these people were held accountable, this technology would work and be successful in the Philippines.